anything you want me to work on. To find vertical asymptotes for a function, we do this and that and determine this and determine that. What? So this is an example of a function. So to find vertical asymptotes for this function, we do what? What are the steps?
So the denominator is equal to 0.
Yes. We find x values for which x plus 1, x minus 3 is 0. Yes, and those are?
-1, +3.
X equals -1 and x equals 3. These will be the vertical asymptotes because these factors do not simplify with the factor from the top. This is it. There is no hole in the graph. Awesome. Next, to find horizontal asymptote, or asymptotes if you want. For this function, what do we need to do? For horizontal, we set the denominator equal to 0. We know that that's not allowed, basically. So then that's why these become vertical asymptotes. And we also have to determine the limits left and right. But in order to find horizontal asymptotes,
divide the highest degrees.
yes. So we factor out. So in other words, we determine the limit. We find the limit as x approaches infinity and also the limit as x approaches negative infinity. Indeed. So we have 5x squared plus 1 over -3x squared plus 2x plus 1. And that's the reason why we factor out the degree, which is x squared in this case for both. It doesn't matter. I do not establish what I factor out in the numerator based on the denominator. No, it just happens that they are the same. Can anyone tell us what we have left inside for the first one, for the top?
5 over -3.
So we have 5, because 5 times x squared is 5x squared, and then plus
1.
But 1 times x squared will not give us 1. So what should I put here times x squared to give us 1? Wait, it must be a fraction. There is no other way.
Is it 2 over 1?
So 1 multiplied by something, I'm sorry, 1 equals something that we determined times x squared. So this piece has to be 1 over x squared because only 1 over x squared times x squared will give us 1. So we have 1 over x squared. X squared times 1 over x squared will give us 1. Good. What about the 3 terms inside here? Can anyone help us with those 3 terms?
-3.
Excellent. The first one is -3. Awesome. Then I have plus. It must be a fraction because I cannot factor out x squared from 2x. So it must be 2 over something. So yes, indeed, because x squared multiplied by 2 over x, we simplify one of these two and we get 2x back. Awesome. Plus, last one, plus. Plus what?
1 over x squared.
1 over x squared, indeed. 1 over x squared. Then we simplify. We have to simplify x squared with x squared. So you said 1 over x squared. Awesome. And now we have to identify where these are going. This, this, and this. Based on this fact, Where is this going? Where is this going? Where is this going?
Infinity.
1 over infinity.
Mm.
2 over infinity. 1 over infinity. What do you think? I have $1 and I want to divide it by all people in Maryland. I don't know how many millions we are.
0.
0. Yes, yes, yes. 0. So 1 over infinity approaches 0. Yes. Good. Okay, then. So that the result is
-5.
negative 5/3. This is it. So y equals negative 5/3 is the horizontal asymptote. Awesome. Great job. When we contribute to the discussion, we always learn. So that's why I want everyone to be involved. Awesome. Great job. I hope this is better now. You feel better about vertical and horizontal. Now, your questions. Anything you want, I'm ready. Anything you'd like to work on, anything you have questions on, anything you worked on, anything you need help with, I'm ready, please. Nothing?
Can we go on over the homework?
Anything you want. You name it.
Yeah, I can go over the homework.
I'm not sure what it was. I didn't write solutions yet. I will post solutions. You know where the solutions are, right, everyone? Each and every homework solutions has, and each and every written homework has solutions posted.
It was f of x equals 3x squared over 6x squared.
I see it. So determine the horizontal asymptote of each function. That's all we are asked to do. So this was exactly what we just did. So since the degrees are the same, is the leading coefficient over the leading coefficient. We just showed all the steps, right? So it's exactly the same. So it will be 3 over 6. So y equals 3 over 6, or y equals 1/2 is the horizontal asymptote. Applying the exact same procedure. So you have to determine the limit as x approaches infinity, and negative infinity will make no difference. For such a function, they're all both the same, of 3x squared over 6x squared plus x, and you have to factor out x squared. So limit as x approaches infinity. We only factor from the denominator, so we have x squared, and this is 6 plus 1 over x. You simplify. This will approach 0, only because this x approaches infinity. And you have 3 over 6, or 1/2. Good. Anything else? Okay, so we know that there are horizontal asymptotes. We know there are vertical asymptotes. But there is something also called slant. Slant asymptotes. So a horizontal is something like this. Of course, a vertical is something like this. A slant is something like this or like this. So in this case, the function follows this number to the left and to the right. In this case, where the function goes to infinity or negative infinity. But in this case, it either goes to infinity or negative infinity, and the other option is to infinity or negative infinity. So it will follow exactly like the horizontal asymptote, it will follow the slant asymptote. Rational functions cannot have horizontal and slant. If they have horizontal, cannot have slant. And if they have slant, they cannot have horizontal. So let me show you an example of how to determine this. So rational functions with a higher degree in the numerator than the denominator have slant asymptotes. So for example, x squared minus 4 over x plus 3. The degree at the top is, can anyone give us the degree at the top and the degree of the denominator?
2 and 1.
Yes, indeed. So degree 2, degree 1. Notice that the difference is exactly 1 unit. This function will have a slant asymptote. This function, x to the third plus 1 over x minus 1, will not have no slant asymptote because the difference in degree is 2. The degree of the top is 3. The degree of the denominator is 1. So 3 over 1 will not give us a line. 2 over 1 will. 5 over 4, degree 5 over degree 4 will give us a line. Degree 6 over degree 5 will give us a line. So the difference in degrees must be exactly 1. In other words, not the other way around. The numerator has to have a degree by 1 unit larger than the denominator. So always the top 1 degree larger than the denominator. Fine. So can anyone tell us quickly what is the vertical asymptote of this function?
-3.
Yes. Very good. Thank you so much. Okay. Now we want to find the slant asymptote. So this function has a slant asymptote. To find the slant asymptote, we have to divide. We are dividing the numerator, x squared space, because the term with the degree 1 is missing, minus 4, and I divide by x plus 3. This is the long division. Anyone remembers a long division for polynomials? It's okay if you say no, we'll go through it anyway. Anyone?
Yeah.
Okay, so what times x is x squared?
X.
Yes, thank you so much. We have to distribute. We are distributing to both. We change the sign and write underneath. X times x is x squared, but we need to subtract. X times 3x times 3 is 3x. We need to subtract. See, that's why I needed the space, because I couldn't put negative 3x under negative 4. They're not like terms. So these go away. Then I have negative 3x minus 4. Final question. What times x is negative 3x?
-3.
Excellent. I go back and distribute to both. Negative 3 times x is negative 3x, but I change the sign because I subtract. Negative 3 times positive 3 is negative 9, but I have to change the sign. These two go away, and negative 4 plus 9 is 5. How do I write this function? Using the information I have right now. Here's how I write it. Exactly like we write 10 divided by 3. How do I write 10 divided by 3? Well, very simple. It's 3 integers plus 1 remainder over 3. You can say that we don't write it like this. We write 3 and 1/3. Correct. The reason I wrote it like this is because this is the only way we can write the answer for polynomials. So the function was x squared minus 4 over x plus 3 equals the quotient. This is the quotient, x minus 3, plus the remainder, which is 5, the remainder, which is 5, divided by the same thing, the divisor. This is the only way we can write it. For numbers, is this or this, for numerical fractions. But for polynomials, we have to write the symbol. I cannot omit and say x minus 3 and then 5 over x plus 3. This works for numbers, but not for polynomials. It turns out, and you will tell me, when x approaches infinity or negative infinity, where is this going? For the limit as x approaches infinity from 5 over x plus 3. Where is this going? When x approaches infinity. 5 over infinity will approach?
0.
Exactly. That's the reason why this does not matter when we establish or find the slant asymptote. This is it. Y equals x minus 3 is the slant asymptote. And it's a line with a positive leading coefficient, which means that the function will go to positive infinity here and to negative infinity here. I'm not going to ask you to graph these, but I want to show you the graph. So allow me to just share my screen so you can see what's really happening. So the graph, the function was x squared minus 4. Don't forget parentheses. If we don't use parentheses for rational functions, we're not going to get anything. Always x plus 3, unless it's just one term, yada yada, you know that. In the graphing calculator, I need to enter the slant asymptote by hand. We just determined it. It's x minus 3. Okay? So now, I know that the vertical asymptote will be a negative 3. The graphing calculator might not even show it, but I know it has to be there at negative 3. And I'm going to use the standard viewing window. So window 6, it's this one. No, it's not. Sorry, the zoom 6. Zoom 6. And let's see what happens. So there is a vertical asymptote at negative 3. This is the slant asymptote, which is x minus 3. As you see, the function approaches infinity here, but there is something missing. It's all the left-hand side of negative 3. So I have to change the viewing window. I don't know how far south, if you want, I have to go, but I have to try, because this is not enough. This is not the graph. So I'll go to a negative, I'm going to say negative 30 with a scale of 5. Y minimum, I'm not sure. I'm going to say negative 60 to positive 10 with a scale of 10. I have to see the left-hand side of the vertical asymptote, which is x equals negative 3. If I don't, I'll have to adjust the viewing window again. Great. So the graph to the left-hand side of x equals negative 3, it's coming from negative infinity, approaching the slant asymptote, and down to negative infinity. And on the other side, it's coming from positive infinity and approaching the slant asymptote towards infinity. I will not ask you to graph these, but I want you to see one example. And we will be asked to determine the slant asymptote.